Look at this problem now where we're going to load cargo of grain, storage factor given, initial displacement, initial kg given, all 5 holes are to be loaded full, and then the tween decks are to be loaded as shown. Using the stability data booklet we can get the data we need, and using the maximum permissible grain healing moment table, let's see if this vessel complies. So what we have to do first of all is set out our table. Students often forget to actually put the 5 holes in because they just go straight to the tween deck, but it tells us quite clearly all 5 holes are full. So we go into the data booklet and get the volume. We divide that by our stowage factor given 1.57, and that will give us the weight. We multiply it by the kg, which is given in the tables, and that will give us the moments. Another common mistake students make is to forget the initial displacement. So put that in first in your table, initial displacement, kg moments. The kg and the volumetric healing moments and the volume we all get from the data booklet. So we just go straight into the data booklet for 1, 2, 3, 4 and 5 holes, get those volumes, and that's fine. We can just feed the information across and work out the weight and the moments and the volumetric healing moments. When we have part full tween decks, then there's a separate table for those. We just go to the ullage of 1.25, the ullage of 3, and we get the values to feed in to the table. And we can see that the tween decks with an ullage, you can see that the volumetric healing moments are far greater, and that will be because that grain can move and can shift in the hold. So we end up with our final displacement, divided the moments by the final displacement to get our final kg and our final volumetric healing moments that we have on board. Divide the volumetric healing moments by our stowage factor of 1.57, and that is the maximum healing moments that this vessel can have on board. So we found what our maximum value is, so now we have to go into the table, the maximum permissible table, and work out what is permissible at this displacement in kg. So I've just brought it up here. We go along the top, along here to get our kg. You can see their fluid kg, and we go between, in this problem here, we're going to go between 6.8 and 6.9. Then going down the table, we go across to our displacement, 19,000, 19,500, and we can see that we need to pick off 7577, 7157, 7700 and 7339. So I've gone in the tables and I've picked those values off, and I've written it out here. kg 6.87, so I've gone between 6.8 and 6.9. Displacement 19, 19500, we're between those two, so I've got those 4 values down. Now I'm going to work out the healing moment value for our displacement. So I'm going to go from 19,000 to 19,500, which is 392. Divide it by 500 and multiply it by the difference between these two values. So in this instance, 392 over 500 times 193 gives us 151. I then apply that to the 7577 because I've interpolated that way down, so I get 7728. And this one here, again, the same situation, 7300. And it's worth looking at this point to make sure that these two values fall between those values there. Now I carry those two forward. So at 6.8 I've got 7728, at 6.9 7300, my kg is 6.87, so again I'm going that way to 6.9, 6.8 to 6.87 is 0.07, 6.8 to 6.9 is 0.1, the difference between these two is 428, so I get 300, so I go down from 7728, so my maximum permissible is 7428. So that's how you do what we call our double interpolation to get the maximum permissible grain healing moments. Now as long as our vessel has less than that value, we can comply. So I've written them there that we've got maximum healing moments for 7428, our vessel complies. The second part says, well, what would be the approximate angle of heel? This formula is on your formula sheet, and we know from the grain rules that the maximum is 12 degrees. So divide our weight heel moments by the maximum permissible, multiply it by 12, and that will give us an angle of list that we would, approximate heel that we would get, heel or list, at 9.7 degrees. So that's how you solve that problem. Quite straightforward, but don't forget the initial displacement, put that straight in, and don't forget, of course, your number 1 to 5 holes. And quite a straightforward problem, particularly if you like drawing out tables like that, then it becomes reasonably straightforward. But just be careful when you've got so many numbers to check what you've written down.